Hi guys, I hope you're doing well. Okay, so for today we are going to continue with the physics, and I'm going to continue with the impulsive force and also weight. So by today I'll be finishing your chapter 2. Alright, so let's not waste time. Okay, impulse and impulsive force. What do we mean by impulse and what is impulsive force? Now, if you look at the definition here, they give you that impulse is the change in momentum, and then impulsive force is the rate of change of momentum during collision or explosion. So what do we mean by all these things? Okay, so what do we mean actually? Okay, so technically, impulse is actually an action that you do to change the motion of an object. So let me give you one example, alright? So let's say if I have a box here, okay, tiramisu barrels, alright? So when I release the box and I slap, okay, the box, and the box will definitely fly away, right? So if you see here, okay, so the action that I'm doing here is what we call the impulse. Okay, so technically impulse is the action, alright, that we do to change the momentum or the movement of an object. So in your everyday life, basically you are doing impulse. When you go to toilet, when you open the door, it's a type of impulse. Or what they call this one. If you play badminton, when people serve the shuttlecock to you and you hit back, that is also a type of impulse. Alright, and the force that you apply is called the impulsive force. Okay, so these are the two terms that you need to understand: impulse and impulsive force. Impulse is the action that you do, and then the force that you apply to do the impulse is called impulsive force. Okay, so technically we are going to expand the formula given from the Newton's second law, F equals to ma. If you substitute the acceleration formula inside, you are going to get the formula for impulsive force. Now if you see here, alright, the definition for impulsive force is the change of momentum over time. Now the time taken here is referring to the impact time. Okay, so impact time, if my impact time is lower, meaning my impulsive force will be larger. Okay, and vice versa, if I increase my impact time, my impulsive force will be lower. Okay, so remember that force, the unit is Newton. So later on you need to look at different situations, so you need to be able to identify in which situation should we decrease the time so that we can produce a larger impulsive force, or should we increase the time so that we can produce a smaller impulsive force. So impulse, how to calculate impulse is that you take the time, you bring over, and then you multiply to your force. So in your questions, they might ask you two different questions. One, they ask you to calculate impulse. Another one, they ask you to calculate impulsive force. Now, most of the time you will be calculating impulsive force, but just in the case if they ask you to calculate impulse, remember, to calculate impulse, the formula is Ft, or change in momentum. Okay, so technically impulse, alright, two ways to calculate. One is you calculate F multiplied to T. Another way is you take mv minus mu. Okay, so these are the two formulas for you to calculate impulse. Alright, and impulse is equals to rate of change in not rate of change, it's the change in momentum. Okay, remember that your unit mass must be in kg. Okay, mass must be in kg. U is your velocity. Okay, unit must be in meter per second. Alright, if they give you what they call centimeters per second, you need to change to meter per second. Alright, so the unit for impulse is Newton second. Okay, and then another important thing that you need to know is that both are vector quantities. Alright, so it's shown here, both are vector quantities because both have what they call velocities. Okay, so remember that impulse and impulsive force are vector quantity. Alright, so we are going to apply the theory of your impulse and impulsive force. Now, we always need to determine the relationship between time and impulsive force. Okay, how does time affect your impulsive force? Now, this one is very important in your questions in your exam. They will always ask about these two things. How does time affect your impulsive force? So, if you look at the example here, right, a student throws a raw egg at high speed, okay, to a wall. Another one they throw to a towel. Which one will break? So obviously the one that hits the wall will break, right, instead of the one with the towel. Okay, so why does this happen? Okay, so let's look at the example here. All right, so you see when he throws the egg to the towel, the egg does not break. Now, this is because the towel increases the impact time, meaning they prolong the impact time. So as you increase the impact time, your impulsive force will be lower. So as you have lower or as you face lower force, that is why the egg does not break. Now, let us see what happens when they throw it from the top and then it hits the ground. Now, if you see here, the moment it hits the ground, all right, because the impact time is short, meaning the egg and the ground, when they hit a bam, the impact time is very short. Therefore, you experience a larger impulsive force, hence the egg will break. Okay, so this is the relationship between time and impulsive force. Alright, so if you see the explanation here, the egg is stopped by the wall in a very short time interval. Okay, meaning this is short impact time. Therefore, you will experience a large force, therefore it breaks. Now, when you throw to the towel, okay, the movement of egg is stopped in longer time interval. Therefore, the impulsive force is smaller. Okay, now in both cases, the eggs are stopped, but the change of momentum is the same, meaning the impulse is the same. Okay, but just that one breaks and one does not break lah. Alright, so the summary given here, the shorter the time taken. So remember, the time taken here is referring to the impact time. Alright, so impact time meaning the what they call the moment, the point of contact between two objects. Okay, if the impact time is shorter, the impulsive force will be larger. If the impact time is longer, all right, the impulsive force will be smaller. So another example is like this. Let's say I take my hand and then I slap my face. So I'm going to show you two conditions, two situations. First situation, if I take my hand and slap my face, but my face move together with the hand, what happens is that, if you can see, all right, because when I move my head together with the hand, I am prolonging the impact time. So as I prolong the impact time, my impulsive force will be smaller. That's why I don't feel that pain. Now, second situation, if my head remains stationary, meaning this time I don't move, I just take my hand and then I just slap. Alright. Oh, okay. So because the impact time is now shorter and I experience a larger force, that is why I feel very, very pain. Okay. Wow. Alright. So I think you understand the meaning of the what you call impulse and impulsive force and how time affects the impulsive force. Alright, so here we are now going to introduce the Newton's third law of motion. Finally, his third law of motion, which is what we call the action and reaction. Okay, so according to Newton, to every action there is an equal reaction in the opposite direction. Okay, so remember that previously when we learned about explosion, okay, opposite direction, right? Explosion, when an explosion happens, the two objects will always go in opposite directions, right? So explosion is actually a type of an example of Newton's third law of motion, right? So technically what we say is that, well, this is my third law of motion lah. Okay, if I slap you, of course your face will feel pain, but my hand also will feel pain as well. So that is the action and the reaction. Okay, so let's look at a few examples here. All right, so the boy, you can see that he's pushing towards the wall. but the wall is not moving because the wall is also producing what they call an opposite force. Okay, therefore it cancels out and it's not moving in this case. Right, now if you are pedaling a boat, okay, so when he takes the pedals and then he roll it backwards, meaning this one goes to the back, okay, the boat will go to the front. Okay, so this is another type of action and reaction. Okay, another example is your rocket. This one is very obvious. All right, when the exhaust gas explodes, so the gas will go down. So this one is your action. So what is the reaction? The rocket will go upwards. So all these are the examples of your Newton's third law of motion. All right. So we are going to look at a few examples where we need to know when to reduce the impulsive force, when to increase the impulsive force. Now, the first one is to reduce impulsive force by increasing the time of impact. Okay, so high jump, there's a reason why we put a mattress, and the mattress normally is a soft mattress. Okay, so the reason why we are putting a soft mattress is because in this case, the soft mattress will increase the time, hence the impulsive force will be lower. So because it's soft, right? So when you jump and then when you hit the mattress will go downwards, right? It will bend downwards. Okay, so this one lengthens the time of impact, therefore reducing the force. Therefore, you will not get injured. Imagine if you jump and then you hit the wood, your mattress here is not a soft but a hard one like a wood. You're going to crack your head, okay, like an egg. All right. So long jump, why we put sand? Why we don't put cement? Logic, right? If you put cement, your legs will get injured. Okay, sand because they absorb your what they call impact time, so they lengthen the impact time, so the impulsive force that you will experience is lower, so you don't get injured. Okay, and then I believe you have seen this before in any docks or at the jetty. You will see that around there they will put the tires here. All right, so why they put all the tires here is that when the boat comes and hit the tire, then the boat will stop, right? So this one, the tire, okay, also same thing, they lengthen the impact time, reduce the impulsive force. Okay, so okay, jump, this fella, when you jump naturally, if you don't believe me, you can try it, when you jump, naturally your knees will bend. Okay, instinctively your body will react. So how you react when you jump and you fall down, right, is that your legs will automatically they will bend one. Okay, so why do they need to bend? Because the moment that you bend, you are increasing the impact time. All right, so I'm going to show you another example, which is this one. Okay, so this, if you see here, when you jump down, right, and then when you bend your knees, you are actually increasing the impact time. So as you increase the impact time, you are reducing the impulsive force. That is why you don't get injured. Okay, now if you want to get injured, can you just straight come down like this, you don't bend. Definitely your leg will break. Okay, so oh my god, I got shot back here. Alright, so there are a few what they call applications of this thing. That's why you have seat belts, airbags, alright, packaging foam. So all this, the function or the purpose is actually to increase the impact time, reduce impulsive force. Okay, so that it can protect us and we don't get injured. Okay, so these are the few examples. Alright, okay, next one will be to increase the impulsive force. Okay, so there are certain times that we also need to increase impulsive force by reducing time of impact. Pestle and mortar, when we tumbuk sambal. Okay, right, so in this case, since you're using hard materials, right, what you are doing is that you are reducing the impact time, okay, meaning the point of contact, because it's hard, and then your impulsive force will be higher. Okay, That is why you can crush the sambal. Okay, let me just write this. Impulsive force will be higher. Your impulsive force will be higher. Okay, so the other examples are like golf clubs or your badminton rackets. Okay, there's a reason why your strings, they will tie your badminton rackets at a certain tension. It cannot be too soft because when it's too soft, you are not going to produce enough impulsive force. It needs to be we call hard enough to be able to return or to hit the shuttlecock. Okay, so these are conditions whereby you need to increase the impulsive force by reducing the time of impact. Okay, so based on the example shown above, right, I can actually summarize into two things. So first thing, if I want to reduce my impulsive impact time and then increase my impulsive force, okay, I am going to use uh, sorry, I need to use hard materials or hard surface. Okay, now if I want to produce a smaller impulsive force, meaning I need to increase the time of impact. Okay, so I need to use soft surface. Okay, so these are the two things that you must know. What type of materials will produce a larger impulsive force? So technically, a harder surface will produce a larger impulsive force. A soft surface will produce a lower impulsive force. Okay, so that is it for the impulsive force chapter. Alright, so this one is an example of safety features in your car. Okay, so when they design the car, right, they need to design in the sense that where, let's say, if you are in an accident, okay, they need to make sure that your impact time will be longer so that your impulsive force will be smaller so that you don't get injured. So that is why we have the safety seat belts, okay, and then airbags, all right. So all this slows down the movement of the passenger, right? So because they prolong the impact time. So as you prolong the impact time, the impulsive force that you will experience will be lower, hence you will not get injured. Okay, so there are certain other features in the car that you must know for your exam. Okay, so this one normally they only will ask in essays. Okay, bumper, all right, to absorb impact. Okay, and then dashboard. If you look inside of your car, right, the dashboard here are all basically made up of plastics, and the reason why is that the plastic will help to absorb the impact. So the dashboard here will increase the impact time, lower impulsive force. Okay, and then there are a lot of other features lah. Okay, so technically if you have a shorter car, if the what they call crumple zone, this is what we call the crumple zone. Okay, so this part here normally is made from materials that can absorb your impact. Okay, but of course the frame of the car will still be made from strong metals like aluminium. Okay, it will not all be totally plastic. If it's all plastic, no metal inside your car, it's basically like a toy car, you know. Toy car, even my dog also can crush the toy car. Okay, so when they design the car, they will make sure that certain parts will have certain materials that can absorb impact so that you won't get injured. Okay, so these are the important safety features that you need to know in your car. Alright, so that is it for your impulse and the impulsive force. Okay, so you can try the questions here, the calculations here. Okay, so here you are going to use the formula F equals to mv minus mu over t, or if they ask you to calculate impulse, for example this one, find the impulse of each object, you need to calculate ft equals to mv over minus mu. Right, so for example like this one, the first question, you are going to use this, okay, mv minus mu. Alright, so same as moving at 9 meter per second, strikes a wall, and then the mud sticks to the wall while the ball rebounds. Okay, so let's say for the first one we calculate is for mud. Okay, so find the impulse, meaning they want you to find this one. This is considered as impulse. Alright, so impulse, I can write it like this also lah. Impulse also equals to right back. Impulse also equals to mv minus mu. So for mud, 0.06 kg, final velocity is 0. Okay, and then minus 0.06. Okay, remember for velocity, if you are moving to the left side, you need to put the negative. Okay, so this one will be 0 minus, will be, oh, how much is this? 54, so it should be 5.4, I think. Alright, so it's negative, so it's negative 5.4. So this one will be 5.4 Newton second. Okay, what about for the tennis ball? Alright, so for tennis ball, okay, so impulse. So tennis ball, both are the same mass, so 0.06. Okay, final velocity, since it's moving to the right, so this one is positive. Okay, this one is negative. So this one will be 3.6 plus 5.4. So will be equivalent to 9 Newton seconds. Okay, so if you notice here, okay, the impulse of the ball, if you compare the two the impulse of the tennis ball is actually higher than the mud. Okay, alright, so you can try the examples the questions here. Later I'll discuss about it. Okay. Alright, so next we are going to go into the next part, which is weight. Okay, this is the final part of the chapter 2. Alright, so you have learned this a little bit before during your form 2 when we learn about forces. Okay, so remember that weight is a type of force that pulls you downwards. Alright, remember weight is a force that always goes downwards. Okay, weight. Okay, it's a force so your unit must be in newtons. Okay, so gravitational field of Earth. So gravitational field strength. Okay, definitely all planets will have their own gravitational field strength, meaning you will experience the gravitational force towards the center of the Earth. Okay, as you go to the center of the Earth, this is what we call a gravitational field strength. Alright, so how they define the gravitational field strength is the force that you will experience, okay, for every 1 kg of mass. Okay, so for every planet, the gravitational field strength for each planet is different. Okay, on Earth, our field strength is this one, 9.81 Newton per kg. If you notice, the unit is the same as your gravitational acceleration. Okay, it's actually the same thing. Alright, so what do we mean by this is that for every 1 kg on Earth, the force that you are experiencing is 9.81 Newton, or we can also say 10 Newton Okay, this one is on Earth. Okay, so let's say maybe let's say if my mass is, let's say, 60 kg. Oh my god. Okay, let's say if I am 60 kg. Okay, so the force that I'm experiencing right now on Earth is technically 600 Newton. Okay, this is on Earth. Alright, If it's on the moon, it will be different, because moon, the gravitational field strength is 1 over 6 of Earth. Okay, so if I calculate my weight on moon, I need to take this one and multiply to 1 over 6. Then that will be the weight of me on the moon. Okay, right? So these two things is actually the same thing. Gravitational field strength and gravitational acceleration, the G here, they are actually meaning the same thing. Okay, so weight, alright, is the gravitational force acting on the object. Okay, so from the formula here, this is how we convert the formula from Newton's second law. Force, since weight is also a type of force, and the acceleration that you feel here is the gravitational acceleration. That is why the formula is equal to this one. W equals to mg. Okay, mass times gravitational acceleration. Okay, mass must be in kg, acceleration must be ms negative 2. Okay, and then your final unit will be your Newton. Okay, so there's a difference between mass and weight. This one you must know. Right, your mass will not change, constant everywhere. If you see the word here, constant everywhere. Okay, meaning that it doesn't matter at which planet you are. If you are 50 kg, you are 50 kg. Alright, but your weight is different. Okay, because weight depends on the gravity. So since every planet's gravity is different, your weight will be different at different planets. Okay, and then mass is a scalar quantity, and then vector weight is a vector quantity. Alright, one is base quantity, one is derived quantity. So make sure you understand the differences between the two things, mass and also weight. Okay, so technically that is it for your chapter 2, done, already finished. Okay, so this one you can try and calculate on your own. Basically you just use the formula W equals to mg, alright, and then you try to find what they want. Okay, but for the first question, if they ask you to find the gravitational field strength, an object weighs 8 kg, right, they ask you to find the gravitational field strength. Okay, you can use this to calculate. Okay, meaning your force or your weight divided by your mass, then you can get your G. Okay, it's actually the same thing as this one, just that we shift the thing to the other side. Okay, so make sure you complete all the exercises, and I will discuss this later on next week. Okay, all the exercises from 2.6 until 2.8. Right, that's it. Bye.